Have you ever really stopped to think about the incredible amount of energy it takes to power our world? I mean, from the light switch you flicked on this morning to the phone that's probably in your hand right now, it's all powered by something. So today, let's dig into where that power comes from and, what it truly cost us.
All right, so first things first, we've got to understand the sheer scale of the challenge we're facing. See, we're not just using a lot of energy, our demand for it is growing at a mind-blowing rate.
And this chart right here, it basically lays out the whole problem for us. The line isn't just going up, it's a steep, relentless climb. Our world is getting hungrier and hungrier for power. And this single, simple trend is at the absolute heart of our entire energy conversation.
So what's driving this insatiable hunger? Well, it really boils down to a few key things. First, there are just more of us on the planet every single day. Second, more and more people are moving to cities and working in industries that, frankly, consume immense amounts of power. And third, as standards of living improve around the globe, so does energy use, which, is a sign of progress, but it definitely comes with a massive challenge.
This huge demand basically forces us to a fork in the road. When you get right down to it, there are two main paths we can take to generate all the power we need.
On one side, you've got non-renewable sources. You can think of these like a bank account with a fixed amount of cash. Once you spend it, it is gone for good. Then you have renewables, which are more like an account that gets topped up every single day. But to really get a grip on our current energy situation, we have to start with the non-renewables, because for right now, they're still the ones powering most of our world.
Let's kick things off with one of the most powerful and, one of the most hotly debated non-renewable sources out there: nuclear power.
So how in the world does it work? Well, it's all about a process called nuclear fission. To put it simply, scientists take the atoms of an element called uranium and they literally split them apart. This one action releases a truly immense amount of energy as heat, and that heat, well, that's the key to the whole operation.
Now, what's so cool about this slide is you can see that whole process in action. Right inside that big containment structure, the fission process is heating up water into super high-pressure steam. That steam then goes and spins a turbine, which is hooked up to a generator, and boom, you've got electricity. The steam then cools back down into water in those giant cooling towers you always see, and the whole cycle just starts all over again.
And this right here really shows you why nuclear power is such a double-edged sword. On one hand, the advantage is huge. You get a massive amount of energy without any CO2 emissions. So from a carbon standpoint, it's technically clean. But the disadvantages are just as big. The tech is incredibly complicated and expensive, and you've got the terrifying risk of radiation leakage, not to mention the still unsolved problem of what to do with all the radioactive waste, which stays dangerous for thousands of years.
Okay, let's shift gears and talk about the energy source that, for better or for worse, truly runs our modern world: fossil fuels. This is literally energy that was captured from our planet's ancient past. So what are they exactly? Well, fossil fuels, we're talking coal, oil, and natural gas, are the result of a mind-boggling geological process. Imagine plants and animals that died hundreds of millions of years ago, got buried under layer after layer of dirt and rock, and were then squeezed by incredible heat and pressure until they turned into the energy-packed fuels we dig up today.
But remember, these are non-renewable. They have an expiration date. Based on what we know we have and how fast we're using it, we're looking at about 114 years of coal left in the tank.
For oil, the picture is even tighter. We've got maybe 50 years worth.
And for natural gas, it's pretty much the same story. Around 52 years left. The clock is absolutely ticking on our main energy sources.
And that ticking clock isn't even the only price we pay, because using these fuels comes with a massive environmental cost.
Just take fracking, for instance. It's a really common way to get oil and natural gas out of the ground. It involves blasting high-pressure liquid deep into the earth, but it has some serious side effects, like the potential for water and noise pollution, and it's even been linked to seismic activity, small earthquakes. And then, of course, there are the accidents. Oil spills can be absolutely devastating. This quote really puts it in stark terms. They cause so much damage to aquatic life that it can actually lead to the extinction of entire species. The stakes just couldn't be higher.
So when a disaster like a massive oil spill happens, the obvious question is, what do we do? How do you even begin to clean up a mess that big?
Well, the first line of defense is usually these floating booms. The idea is to deploy them to kind of corral the oil and just keep it from spreading any further.
Another tactic is to spray detergents on the spill to break the oil up into smaller droplets. But here's the catch. The detergents themselves can be toxic to marine life, especially fragile things like coral reefs.
And finally, you've got skimmers. These are basically devices that try to physically scoop or suck the oil right off the water's surface. It's a direct approach, sure, but it's also incredibly slow and almost impossible to use effectively on a massive scale.
And all of this, it brings us to the ultimate question, doesn't it? Our appetite for energy is just relentless. Our main fuel sources are literally running out, and they come with huge environmental risks. And our ways of cleaning up our own messes are, let's be honest, flawed at best. It all boils down to this one single urgent problem. With the clock ticking and the costs piling up, what is the path forward?